Last example, again, to start off, we always factor completely. And in this one, the factors are the same, so they simplify. Now be careful here. This doesn't mean that your final equation is just y equals x minus 3. Because when you simplify, you're left with 1s. The x minus 3 is in the denominator. It stays in the denominator. And you would have 1 over x minus 3. So number 1, do we have any non-permissible values? Yes. X can't equal 3 anymore, and x can't equal negative 3. Even though it's simplified away, it's still a non-permissible value. One of these is going to be a vertical asymptote, and the other one is going to be a hole. So x equals 3, it's still in, here's our simplified equation. That what we're going to do now is we're going to graph that equation and add a hole to it. So in that equation, we still have a vertical asymptote at x equals 3, because that non-permissible value didn't simplify. But we're going to have a hole at negative 3, 1 over negative 6. Again, take a look. Make sure you can see, where did I get that 1 over negative 6 from? Plugged in negative 3 into that new equation with the green box around it. This one's going to have a hole and a vertical asymptote. We're going to see what that looks like. Okay? Number 2, do we have any horizontal asymptotes or oblique asymptotes? We're going to have a horizontal asymptote where? At y equals 0. Again, once you've simplified it, we're now graphing what's in the green box. So unlike most things in math where you always refer back to the original equation, in these graphing ones, once you've simplified it, for steps 2, 3, and 4, you're going to look at your simplified version, but you're going to add the hole to the end. So when I look at this one, the highest power is an x. We have one x on the bottom. We have no x's on the top. If you're using that technique, that'll also tell you that you have a horizontal asymptote at y equals 0. Or maybe you remember that whenever the degree is larger in your denominator than in your numerator, you always have y equals 0 as your horizontal asymptote. Intercepts. Starting with your y-intercept, if you plug in 0 for x, you will get 1 over negative 3. Again, I plugged 0 into the new simplified one. You might notice that if you plugged in 0 into the original one, you also got the same thing. However, when you're looking at your x-intercept, x-intercept is when you plug in 0 for y. If I plug in 0 for y here, when is my fraction equal to 0? When is the numerator equal to 0? It can't. The numerator is always 1. So we can say that there's going to be no x-intercepts. Can you see if you looked at your original one, you might say, hey, I can make the numerator equal to 0. What would make the numerator equal to 0? Negative 3. But that's a non-permissible value. And so that's where that problem comes up. So we're looking at, for steps 2 and 3, your horizontal oblique asymptotes and your intercepts, you're looking at your simplified version. So now that we have that, we're going to see, do we have enough information to graph this? We're going to have our first vertical asymptote at x equals 3. We have a horizontal asymptote at y equals 0. We can label those. we know that we have a y-intercept of -1/3. And we know that we have a hole at -3, -1/6. So we have enough information to the left of our vertical asymptote to say that our graph looks like this. We still need another point, so I'm going to plug in 4. If I plug in 4 into this equation, can you see that you would get 4 minus 1 would be 1? 1 over 1 is 1. So we'll have the point 4, 1. And then that's enough information in this section to say our graph looks like this. You could have also graphed this using your transformations unit. Do you remember the 1 over x graph? And this would just be the 1 over x graph moved 3 to the right. Does that look like what we ended up with? A 1 over x graph moved 3 to the right. But it has a hole in it. These are usually worth 2 to 3 points because you've got a lot of things that you're going to, if they were graphing it completely, it would probably be a 3-mark question. Just 3 points. Okay? There's no additional questions other than those first 3 that I gave you, 3, 4, and 5. Although surveying the last 3 or 4 exams, the exams seem to like these ones that have vertical asymptotes and holes. Both of them. They like those. There has not been one on the exam yet with an oblique asymptote. It's not to say they're not going to put the first one on there this year, but so far it's been holes and vertical asymptotes and horizontal asymptotes, not oblique asymptotes. So as far as the examples we've done, examples 1, 2, and 4 are more common on the exam than